All right, 7th graders, we're going to take what we did last year with parallel perpendicular lines and do more with it. So what are you going to learn today? You're going to learn how to identify and write equations in parallel and perpendicular lines, and also use them in real-life problems. So we're going to start with our first core concept, which covers parallel lines and slopes. Now, you already know this concept. However, we're going to introduce something new. So let's start with our core concept. Two lines in the same plane that never intersect are parallel lines. Non-vertical lines are parallel if and only if they have the same slope. So this if and only if is something that's new. Now you also should make note that all vertical lines are also parallel. But we're going to introduce something new, and that's called the if and only if. Here it is. The phrase if and only if. So in this example, the phrase A, if and only if B, is a way of writing two conditional statements at once. It means that if A is true, then B is true. It also means that if B is true, A is true. So here's what that means. If I put this as A, non-vertical lines are parallel. B is if they have the same slope. So I can write it both ways. So if I wrote it like this, if non-vertical lines are parallel, then they have the same slope. Or I could say this, if non-vertical lines have the same slope, then they are parallel. Both of those conditional statements are true. It works both ways, the conditional statement and its converse, which means it's an if and only if. It works both ways. It's something called, you're going to learn this next year in 8th grade, a biconditional. A definition, any definition, if it's a real true definition, can be written the same forward and backwards. It's a true biconditional. Now in example 1, I've already done this one for you and have all the work because we've done this before. So we're just going to quickly go over it. Example 1, you need to determine which lines are parallel. Well, we know if they have the same slope. So if you find the slope between 2 points of all 3 of these lines, A, B, and C, you will notice that A has a slope of -1/5, as does C. Therefore, since they have the same slope, lines A and C are parallel. Now in example 2, we want to write an equation of the line that passes through the point 5, -4, and is parallel to the line y equals 2x plus 3. Now I'm going to show you 2 different ways to do this. You only need to do one on an assessment or improving to me your work. So what do we know? We know it's parallel. So if we look here, the slope is 2. Easy. If the slope is 2, we know the slope of the line we want to write is also 2. So I have a slope and I have a point. So I could use point slope form. If I did that, it'd be y plus 4 equals m, which is 2, multiplied by x minus our x coordinate. And I want to simplify this, so y plus 4 equals 2x minus 10. I subtract 4 using the subtraction property of equality, and I get y equals 2x minus 14. That line is parallel to the line up here. So let's use it a different way. Now notice what I did here. I used point slope form. I can also use slope intercept form. And I could plug in 5, -4 as x and y, and m is the slope. So I could get -4 equals the slope, which is 2, multiplied by x, which is 5, and then plus b, which is what I need to find. If I solve this, I get b as -14, which if I took b equals -14 and the slope, which is 2, I get the same answer. Either way is an acceptable way to write an equation. So perpendicular lines. Two lines in the same plane that intersect to form right angles are perpendicular lines. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. Vertical lines are perpendicular to horizontal lines. So, vertical lines are perpendicular to horizontal lines. Their slopes would not be negative reciprocals of each other. Now, you know that negative reciprocals multiplied together would give you -1. So for example, right here, the product of a non-zero number m and its negative reciprocal would always be -1. So looking at our examples up here, the slopes are -2 and 1/2. The product of both of those, since they're negative reciprocals, is -1. So example 3. Determine which of the lines, if any, are perpendicular and parallel. Well, let's look. Line A, the slope is easily 4. Line B, what should I do first? Let's solve the equation for y. 4y equals -x plus 3. Divide by 4. I get -1/4 x plus 3/4. So the slope would be -1/4. Pause the video and solve line C yourself. Pause the video. So you should also notice that the slope in this problem is also -1/4. So parallel. Which lines are parallel? We'd have line B and C. Perpendicular. Which lines are perpendicular? We have two. We have A and B and A and C because their products are -1. All right, example 4. Write an equation of the line that passes through -3, 1 and is perpendicular to the line y equals 1/2 x plus 3. So if the slope of here is 1/2, what would the slope of the perpendicular line to that be? What's the slope? The slope would be -2. So now I'm going to use point slope form. You could also use slope intercept form. So what would I get if I used point slope form? Okay, y minus 1 equals what? -2 multiplied by x plus 3. Good. Let's solve this. Y minus 1 equals -2x minus 6. I now add 1 using the addition property of equality. And my equation would be y equals -2x minus 5. All right, in our last example, it's a real-life problem. The position of a helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents its path. So the shoreline is represented in green. We want to write an equation for the red line. So the first thing we're going to do is find the slope of the red line. So let's see, we have 14,4. It looks like another point I could pick. Looks like I have a couple points here. I could pick either one of these. So I'm going to pick this one, 12, 1. So the slope here is going to be 4 minus 1, which is 3, and 14 minus 12, which is 2. So the slope is 3/2. Now let's make sure we're doing this correct. So let's look at our green line. It looks like I can pick a point here, here, and so on. So this slope is 1, 3, and this, or I'm sorry, it's not slope, the point. And this point is 4, 1. So that slope would be, let's see, 3 minus 1, which is 2, and 1 minus 4, which is negative 3. So we have negative 2/3 and 3/2. So that's correct, because they're negative reciprocals of each other. So I know that my slope is 3/2. 14/4 is my point. So if I use point slope form, y minus 4 equals 3/2 multiplied by x minus 14. That would give me y minus 4 equals 3/2 x minus 21. And if I add 4, y equals 3/2 x minus what? 17. And there's my equation. Y equals 3/2 x minus 17.